Sunsets do not look the same everywhere. The sky above the ocean behaves differently than sky above desert. Humidity matters. Altitude matters. Latitude determines angles and duration. Most people assume sunset is sunset. Orange sky, descending sun, pretty colors. This is like assuming all music is the same because it involves sound. 15 locations produce sunsets that operate according to specific atmospheric physics unavailable elsewhere. These are not opinions about beauty. These are observations about chemistry, geometry, and light behavior at planetary scale. By the end, you will understand why sunset at the equator lasts 15 minutes, while sunset above the Arctic Circle extends for hours. 1. Santorini produces blue hour phenomena intensified by volcanic geography. The island is the rim of a collapsed caldera. The cliffs drop vertically into the Aegean. No gradual slope, straight descent. This geometry creates unobstructed western horizon. No mountains, no trees, no buildings except those on the cliff edge. When the sun sets over water with no obstacles, refraction produces the green flash. This is not metaphor. This is actual green light, visible for 1 to 2 seconds as the sun disappears below the horizon. Green flash occurs when atmosphere acts as a prism. Different wavelengths bend at different angles. Red light bends least. Violet bends most. Red disappears first below the horizon. Violet is absorbed by atmosphere. What remains for a brief moment is green, but this only happens under specific conditions. Clear sky, stable atmosphere, unobstructed horizon, exact angle. Santorini provides these conditions more reliably than most locations. The blue hour after sunset is also enhanced. The caldera acts as a natural amphitheater. Light reflects off white buildings. The volcanic rock absorbs and re-emits heat, creating atmospheric shimmer. The entire island becomes a gradient of blues ranging from violet to cyan. This is not magic, this is physics. Visit Oya for the classic view. But understand, you are sharing the experience with thousands. Arrive 90 minutes early to claim space. Or go to Imerovigli. Fewer people, same phenomenon. The green flash is not guaranteed, atmospheric conditions must align, but the blue hour is reliable. Bring a jacket. Islands cool rapidly after sunset, the wind increases. What you witness is light interacting with specific geography in ways that do not occur elsewhere. 2. Uluru in Central Australia produces color shifts caused by iron oxidation. The rock is not inherently red. It is gray sandstone containing iron minerals. When iron oxidizes, it turns red. Rust. Uluru is essentially a giant rusty rock, but the rust creates spectral properties that change throughout the day. Midday sun makes the rock appear orange-brown. Late afternoon shifts to deep red. Sunset produces purple. This is not perception, this is measurable wavelength shift. Iron oxide reflects different wavelengths depending on angle of incoming light. Low-angle sunlight at sunset emphasizes longer wavelengths. Red and violet dominate. The surrounding desert is flat for hundreds of kilometers. No hills, no trees, nothing to obstruct horizon. This means the sky provides a gradient backdrop. The rock stands isolated against atmospheric color progression. As sun descends, the rock appears to glow. This is not bioluminescence. This is reflected light concentrating on iron-rich surfaces while surroundings darken. The effect lasts approximately 45 minutes. Peak intensity occurs 15 minutes after official sunset. Visit during dry season for clearest skies. Wet season brings clouds that obscure the effect. The Uluru sunset viewing area is crowded. This is unavoidable. Arrive 2 hours early. Bring water and patience. Indigenous Anangu people consider Uluru sacred. Photography restrictions exist in certain areas. Respect them. What you witness is mineralogy interacting with solar angles to produce color shifts invisible in most geology. 3. Atacama Desert in Chile sits at high altitude with minimal atmospheric moisture. This creates the clearest skies on Earth. Observatories cluster here because atmospheric interference is lowest anywhere. Sunset in Atacama is not about the sun. It is about what happens after the sun disappears. The sky transitions through colors that do not appear at lower altitudes. Deep violet, electric blue, colors so saturated they look artificial. This is caused by Rayleigh scattering occurring without moisture to diffuse the effect. Rayleigh scattering is why sky is blue. Shorter wavelengths scatter more than longer wavelengths. Blue scatters most effectively. At sea level, moisture in atmosphere diffuses this scattering. Colors blend. The effect is subtle. At altitude with no moisture, scattering is pure. Colors are concentrated. The result is a sky that looks like a gradient designed by someone who has never seen actual atmosphere. Atacama also provides views of stars and planets appearing immediately after sunset. No gradual transition. Sun disappears. Stars appear. This happens because atmospheric clarity allows light from celestial objects to penetrate without scattering. Visit Valley of the Moon near San Pedro de Atacama. The landscape is surreal. Salt formations, volcanic rock, dunes. Bring warm layers. Desert altitude means temperatures drop rapidly. Sunset warmth disappears within minutes. What you witness is atmosphere operating without the moisture that normally obscures its fundamental behavior. 4. Grand Canyon produces layered shadow progression caused by geological stratification. The canyon is not a uniform depth. It descends in layers. Each layer is different rock from different geological periods. Limestone, sandstone, shale, granite. Each rock type has different reflective properties. As sun descends, shadows climb the canyon walls, but they do not climb uniformly. Limestone layers hold light longer. Dark shale absorbs light faster. The result is a vertical gradient where some layers glow while others darken. This creates banding, horizontal lines of light and shadow progressing upward as the sun sets. The effect is most visible from viewpoints with eastern exposure looking west across the canyon. South Rim provides accessible viewpoints. Hopi Point and Yavapai Point offer the widest vistas. The progression takes approximately 90 minutes. The canyon fills with shadow from bottom to top. The final layer to lose light is the rim. Then, for 15 minutes after the sun drops below the western horizon, the entire canyon glows with reflected light from the sky. This is alpenglow applied to geology instead of mountains. Alpenglow is the pink or red light that appears on mountains after sunset. It is caused by light scattering in the upper atmosphere and reflecting off surfaces that are high enough to still receive that light. Grand Canyon's depth reverses this. Instead of peaks catching last light, the rim catches it while the interior is already dark. Visit during autumn or spring for moderate temperatures. Summer is dangerously hot. Winter can close roads. What you witness is geological time made visible through differential light absorption across rock layers deposited over hundreds of millions of years. 5. Iceland in June produces sunset that never completes. The sun approaches the horizon. It touches. It sits there. It rises again. This is not sunset. This is the midnight sun. At 64 degrees north latitude during summer solstice, the sun never drops below the horizon. The sky transitions from daylight to twilight, then back to daylight, no darkness. This is disorienting. Your circadian rhythm depends on light cycles. Without darkness, sleep becomes difficult, but the visual effect is remarkable. The sun traces a shallow arc above the horizon. The sky remains illuminated. Colors shift from gold to pink to violet and back to gold without ever reaching full dark. This lasts all night. The effect is most pronounced in northern Iceland. Akureyri provides accessible viewing. The best fjords are more remote but less crowded. Bring blackout curtains if you want to sleep, or embrace the experience and stay awake. What you witness is planetary tilt, creating extended day length at high latitudes during summer months. 6. Antarctica in December produces sunset-lasting hours. The same physics that creates Iceland's midnight sun creates extended sunsets in Antarctica. But Antarctica is remote. Tourist access is limited. Expeditions are expensive. The payoff is sunset that extends across 3 to 4 hours. The sun descends toward the horizon extremely slowly. The angle is shallow. The path is gradual. This means the golden hour lasts not 60 minutes, but potentially 200. The light during this extended period is photographers call magic hour, compressed into an extended window. But there is more. Salt creates a perfectly level surface. Water spreads evenly. The result is a mirror at continental scale. Sunset produces infinite horizon. Sky continues through the ground. Clouds reflect perfectly. There is no reference point to distinguish up from down. This creates spatial disorientation. Your brain expects ground to be solid and opaque. The flats violate assumption. People appear to walk on sky. Vehicles drive through clouds. The visual effect is impossible to process without experience. Visit January through best water coverage. Dry season offers different experiences, but no mirror effect. Tours operate town. 3-day tours include sunrise and sunset at the flats. Bring sunglasses. The reflection doubles light exposure. Sunburn happens faster than you expect. What you witness is geological flatness, creating conditions for perfect reflection at scales elsewhere. 10. Norwegian fjords produce sunset that interacts with glacier ice. The ice contains compressed air bubbles thousands of years ago. These bubbles scatter light inly. When sunset light hits glacial ice, it penetrates the surface. Light scatters inside the ice. Some wavelengths are absorbed. Blue light escapes. By glacier ice appears blue. But at sunset, the incoming light is already shifted toward red and orange. When this light enters ice that preferentially emits blue, the result is colors that should not coexist. Blue ice glowing orange sky, violet shadows on white snow, colors that look photoshopped but are entirely natural. The effect is most visible in Svalbard and Norway's northern fjords. Trolltunga and Preikestolen are accessible viewpoints. Require significant hiking. Visit during summer for accessible. These temples create artificial horizon interruptions. Everywhere you look, stupas and spires break the skyline. Sunset from temple tops provides views across this landscape. But the real phenomenon is the smoke. Local farmers burn fields in evening, wood fires for cooking, incense from temple offerings. All this smoke creates particulate matter in the atmosphere. When sunset light passes through smoke, scattering increases exponentially. The sky turns shades of orange and red that are impossible in clear air. This is the same physics that makes sunrise after volcanic eruptions spectacular. Particulates scatter light, but Bagan's effect is human-made and daily. Climb Schwessendal Pagoda or Payathata Pagoda for elevated views. Arrive 2 hours early because tourist density is extreme. The experience is surreal. Thousands of temple silhouettes, smoke rising from dozens of locations, sky transitioning through colors enhanced by atmospheric particles. Myanmar's government restricts climbing on many temples. Regulations change frequently. Confirm which temples allow access before visiting. What you witness is human activity creating atmospheric conditions that enhance natural light phenomena. 9. Uyuni Salt Flats in Bolivia become a mirror during wet season. When rain covers the flats, the surface becomes perfectly reflective. Sky and ground become indistinguishable. Sunset over flooded salt flats creates symmetry. The sun appears above and below simultaneously. This is not illusion. This is reflection. The flats cover 10,000 square kilometers. During wet season, a thin layer of water covers this entire area. Salt creates a perfectly level surface. Water spreads evenly. The result is a mirror at continental scale. Sunset produces infinite horizon. Sky continues through the ground. Clouds reflect perfectly. There is no reference point to distinguish up from down. This creates spatial disorientation. Your brain expects ground to be solid and opaque. The flats violate this assumption. People appear to walk on sky. Vehicles drive through clouds. The visual effect is impossible to process without experiencing it. Visit January through March for best water coverage. Dry season offers different experiences but no mirror effect. Tours operate from Uyuni town. 3-day tours include sunrise and sunset at the flats. Bring sunglasses. The reflection doubles light exposure. Sunburn happens faster than you expect. What you witness is geological flatness creating conditions for perfect reflection at scales unavailable elsewhere. 10. Norwegian fjords produce sunset that interacts with glacier ice. The ice contains compressed air bubbles from thousands of years ago. These bubbles scatter light internally. When sunset light hits glacial ice, it penetrates the surface. Light scatters inside the ice. Some wavelengths are absorbed. Blue light escapes. This is why glacier ice appears blue. But at sunset, the incoming light is already shifted toward red and orange. When this light interacts with ice that preferentially emits blue, the result is colors that should not coexist. Blue ice glowing against orange sky, violet shadows on white snow, colors that look photoshopped but are entirely natural. The effect is most visible in Svalbard and Norway's northern fjords. Trolltunga and Preikestolen are accessible viewpoints. Both require significant hiking. Visit during summer for accessible trails. Winter hikes are dangerous and require technical skill. What you witness is ancient ice containing trapped atmosphere from different eras interacting with modern sunlight. 11. Masai Mara during dry season produces sunsets enhanced by dust from the savanna. The grasslands are parched. Animal movement kicks up fine dust. Wind carries this dust hundreds of meters into the air. When sunset light passes through this dust layer, scattering creates deep red tones that are uncommon in humid environments. The dust also creates atmospheric haze that softens the sun's appearance. Instead of a harsh disk, the sun becomes a diffuse glow. Acacia trees provide foreground silhouettes. The flat landscape creates uninterrupted horizon. The combination of dust-enhanced color, tree silhouettes, and often wildlife creates compositions that are distinctly African. Visit during dry season for maximum dust. Wet season offers different experiences, but the air is too clear for the enhanced red tones. Safari lodges position sunset game drives to optimize viewing. Costs are high, but the access is worth it. What you witness is ecological conditions creating atmospheric properties that amplify specific wavelengths during sunset. 12. Patagonia's mountains create lenticular clouds that catch sunset light. Lenticular clouds form when moist air flows over mountains. The air cools as it rises. Moisture condenses. Clouds form. But these clouds are stationary. They hover over peaks, regardless of wind, because they form from the mountain itself, creating the disturbance. At sunset, these clouds catch light while the ground below is already in shadow. The result is clouds glowing pink and orange above darkened mountains. The contrast is extreme. Black peaks, glowing clouds. Lenticular clouds also have distinctive shapes. Smooth, lens-shaped. They look artificial. The combination of unusual shape and sunset color creates images that appear digitally manipulated. Torres del Paine National Park produces lenticular clouds frequently. The Andes create the atmospheric conditions required. Visit during summer for accessible trails. Winter is brutally cold but produces even more dramatic clouds. What you witness is orographic lift creating cloud formations that interact with sunset light in ways flat terrain cannot produce. 13. Namibia's deserts produce sunset over dunes that create shadow patterns. Dunes are not uniform slopes. They have ridges. The sand accumulates in specific patterns determined by wind direction. At sunset, the sun angle becomes shallow enough that every ridge casts a shadow. This creates linear patterns across the dunes, light and shadow alternating. The pattern shifts as the sun descends. As sun angle decreases, shadows lengthen. What was a thin line becomes a wide band. The color of the sand also matters. Namibian sand is red because of iron oxide. At sunset, this red sand reflects orange light. The combination intensifies the warm tones. Sossusvlei is the most accessible dune field. Dune 45 is a popular sunrise location, but sunset works equally well. Climb a dune an hour before sunset. Watch the shadow patterns progress. The changes are subtle but continuous. What you witness is geological formations creating three-dimensional light interaction that flat surfaces cannot replicate. 14. Maldives sunsets occur over water with no land masses to interrupt the horizon. This creates a pure gradient. Sky transitions from blue at zenith to orange at horizon with no interruptions. The water also matters. Ocean surface reflects sky. As sky changes color, water changes color. During sunset, the ocean becomes a mirror of the atmospheric gradient. Clouds appear both above and below the horizon line. One set in the sky, one set in the reflection. This symmetry is hypnotic. Where does sky end and water begin? The answer depends on whether you focus on the horizon line or the color gradient. Maldives also sits near the equator. Sunset happens quickly. The sun descends vertically rather than at a shallow angle. This means the transition from day to night takes approximately 15 to 20 minutes. No extended twilight. The speed is disorienting. Colors shift rapidly. The sky is orange. Then it is dark. Stay in overwater bungalows for unobstructed views. Beach resorts work equally well. What you witness is equatorial sunset over uninterrupted ocean, creating pure atmospheric color gradient. 15. Ha Long Bay in Vietnam produces sunset among limestone karsts. These formations rise vertically from water, sheer cliffs, vegetation on top, no gradual slopes. When the sun sets behind these karsts, silhouettes create dramatic contrast. But the real phenomenon is the mist. The bay is humid. Water evaporates constantly. Mist forms in late afternoon. At sunset, this mist catches light. The air glows. Visibility decreases. The karsts appear and disappear as mist shifts. This creates an ethereal effect. Solid rock becomes ghostly. The landscape feels temporary. Boat tours operate throughout the bay. Sunset cruises are common. Crowds are unavoidable. The best viewing happens when mist is thick. This requires humidity and calm wind. What you witness is geological formations interacting with atmospheric moisture to create conditions that obscure and reveal landscapes simultaneously. These 15 sunsets share one common element. They occur under conditions unavailable in most locations. Volcanic geography. Dust from migration, ice from ancient atmospheres, lenticular clouds from mountains. Sunset is not just the sun descending. Sunset is light interacting with whatever exists between the sun and your eyes. Atmosphere, particles, moisture, geography. Each location on this list provides specific conditions that modify how light behaves. You cannot see green flash in a forest. Trees block the horizon. You cannot see lenticular clouds in flat terrain. Mountains create them. You cannot see mirror reflections in rough topography. Flatness is required. This is why location matters. Most people watch sunset from wherever they happen to be. This is fine. Sunset is beautiful anywhere, but if you want to understand what light can do under optimal conditions, you need to go where those conditions exist. Santorini for green flash, Uluru for iron oxide color shifts, Atacama for atmospheric clarity, Grand Canyon for geological layering. These are not opinions. These are physics operating at specific coordinates. Your choice is simple. Witness the phenomena, or accept that you prioritized convenience over understanding. Most people choose convenience. That is why most people see average sunsets. These 15 locations offer something different, not better, different. They show you what happens when light interacts with extreme conditions. Pack accordingly. Bring cameras. Arrive early. Accept crowds. What you witness is planetary physics operating at scales and intensities that redefine what you thought sunset could be. The next video explores why some atmospheric phenomena occur only once per year in specific locations, and why understanding celestial mechanics changes how you plan trips around light instead of landmarks.